Hello, everyone. Welcome to our presentation today. I'm Haluk Ulubay, Senior Director of Marketing at DataCore. I'll be your host today, and we'll talk about the next generation data centers and data infrastructure, data architectures that kind of support those next-gen DCs. So let's move on and kind of talk about DataCore a little bit, who we are and what we're doing. We have, as of today, more than 30,000 deployments worldwide and more than 10,000 customers. We have a 10th generation product, software-defined storage, and we work with all companies in all industries and sizes. Our key markets really are software-defined storage and hyperconverged infrastructure systems. And our technologies that we have, our key technologies are storage virtualization and parallel I/O, something that makes us really unique in this space. And I'll talk about that later in the presentation. We are a worldwide company. Main offices in, as you see on the right-hand side, in many different countries, and we follow the sun for our support model, and our support is available 24/7 by 365, anywhere in the world. So that's shortly about DataCore, right? And let's just talk about a little bit, what happened, kind of history, how we got here today, and what we have. So in 1980s, right? It was a very simple world. We had data, basically server storage. We have servers out there, storages on them, and people were happy. And then as data started growing and high technology came in line, in 2000s we see shared storage really popping up, network attached storage area networks, things like these, in addition to the servers and storages on them. Coming today, from 2000s, we have a pretty complicated picture, right? I mean, we still have servers, barebone or virtualized. We have hyperconverged systems, and we have a plethora of devices that are mostly incompatible with each other in terms of management and software, etc. We have, flash arrays, hybrids, new stuff keep coming online every day, and we have cloud also, which impacts the architectures and economics in a big way. So, challenges. What are the challenges, right? These are our pain points that kind of we live through every day. Data grows, and capacity for data, that growth is hungry, right? We are all hungry for that capacity. Lots of incompatible devices out there in our data centers. And of course, every one of them needs a new software. They need maintenance. They need upgrades for all of these, each and every one of these devices. And thus we kind of, see a lot of silos of storage out there in data centers. And that creates a diverse and complex management situation that we have to deal with every day on the IT departments, especially. So we do, of course, as most people do, most companies do, we do surveys. So out of our surveys, right, customer base and even prospects, we see these 4 type of projects keep popping up. Application performance. We're going to talk about that a little bit more later, but, applications are slowing down, even maybe after virtualization, and we need to add storage to it, and how do we make them run faster? BCDR, right? Business continuity and disaster recovery is always and will always be probably a key project, so important. Storage expansion. This started popping up more and more in the last 5 to 7 years. Why? Because data is growing like crazy, and we all have to keep up with the with that data growth, right? And then storage refresh. This is an age-old, refresh story, right? And always a key project, especially if you're working with a single vendor, or even multiple vendor situation. Hardware needs to be replaced and refreshed. Those cycles, we try to sweat the hardware more and more, but still you have to refresh them at the end of the day because technology goes so fast. And of course, there are other projects as well, but these are kind of the main four ones we see all the time. So kind of digging deeper into these challenges a little bit and situations, the key projects, slow applications, right? Poor performance of your important applications, business critical applications. A lot of people, right? 70% of them of us still see slowness, the poor performance, and almost 2/3 of our customers or prospects have experienced slow applications, even after server virtualization, which kind of makes you go, it's not compute maybe. There's something else going on down there, right, that we need to look into. And we'll talk about that. And due to storage, of course, people do experience, 4 out of 5 almost, do experience I/O problems, even after the virtualizing the servers, the virtualizing the compute, and slowing application responses, more than 1/3 of them. So on the graph, one reason, right, why this is happening. One reason is this. You see the compute gains. We all know the Moore's law, right, on chips and computers. But, relatedly, right, compute makes pretty significant gains every year. At least it has, right? And nowadays, as the clock speeds saturate, right, on the chips, now designers are squeezing more and more cores into chips, right? 2, 4, 6, 8, 11. It keeps going up, more and more cores. So compute is fine. Compute is growing. But look at the storage, especially the spinning disks and that kind of storage. There isn't really much innovation you can do anymore on those, and annual gains isn't really that much. It's almost flat. Thus, the situation is we have a lot of compute power out there, but the storage performance has fallen significantly behind. So we can do something about it, though. There are different solutions, right? For instance, it's a 76% here, but I'll say 100% of us are either using, implementing, or evaluating flash storage. It's fast. It's kind of expensive still. And some of us who actually put in flash into our architecture actually saw that it didn't really accelerate applications. Again, something that makes you go, interesting. We have to think through this. And flash is still more expensive than, of course, hard disks. And you don't want to really waste your flash on cold data. If you think about a data bit's life cycle, right? When you put it in your storage, it's accessed pretty frequently. It's hot data. And then it kind of starts getting colder. It becomes warm. And after a while, that data never gets accessed anymore, or very minimally. That's cold data, right? You don't want to keep a lot of cold data on your flash. So you need to do something about it. Something to think about, right, as we kind of go through DataCore solutions. Availability, BCDR, right? Business continuity, really important. And out of our surveys and actually from different research groups out there, we still see about 20% of the companies experience storage failures, and which caused downtime. These are mostly human errors, sometimes facility problems, and sometimes really a technical problem. But I heard this story from a friend of mine. They had an air conditioning problem in one of their data centers. They sent the guy in. he sees there is a leak, and he decides to fix it. How do you fix a leak on a copper, little pipe? Well, you solder it, right? So he pulls out his little torch for soldering, and as soon as he lights it up, of course, sprinklers kick in, and it's a disaster. The whole data center goes offline, and it takes hours to bring it back. And downtime is still expensive. Gartner says it, IDC says it, everybody says it. It's hundreds, if not thousands of dollars per minute, depending on how big your business is. So it is really important, right, to take care of your high availability and continuity. In the picture here, you see there is a cluster in the compute. So servers are redundant. They are available, highly available. That's great. But look at the storage. That box is redundant, right? It has power supplies, dual power supplies in it. It has dual racks in it. Guess what? It's not highly available. If that box gets flooded, you're in trouble. So, moving on. I talked about data. Data is growing faster. Well, data doubles, I think, nowadays every 2 years. So that's a 25% annual increase. There are more sources of data. There is human-created data. There is machine-created data. All these sensors out there, our cars, refrigerators, Internet of Things, alarm systems. They're creating huge amount of information, as you know. And well, I looked it up last night, right? YouTube, human-created data. Every minute, 300 hours worth of video is uploaded to YouTube. They have more than 1 billion users. I mean, just that, right? It's crazy. So we know it's out there. We know this acceleration speed probably is going to increase also. And we used to keep, what was the advice? Keep your data for 3 years. Now, and then it became kind of, okay, you need to keep it really for 7 years. Now I'm hearing a lot, don't delete your data. Just archive it, put it somewhere, don't ever delete it. Because there are many implications, litigation, and all sorts of things, right, that you have to go back to your old data sometimes. So let's move on and look at the silos. So with all this in context, right, all these challenges, growth, continuity, etc., let's look at kind of what we have. Typically, if you're not a single vendor data center, you have silos. These are all reputable vendors, right? I mean, Dell EMC, Nutanix, and they have different products. These are just examples, by the way, not picking on the vendors. But anyway, they have their own little management systems. They have their own storage and northbound interfaces to applications. So they are siloed, by the way, basically. And the numbers down here is 64% have arrays from 3 or more storage vendors. Again, these are from our own surveys and industry research as well. And there is a need out there still to simplify the management of all these mixed storage environments. So this is a silo environment that provides different features and services, storage services to the upward layers. One box might create caching and replication. The other one might just do replication and snapshots. It's kind of heterogeneous as well, which creates difficulty for all the IT people out there and line of businesses who want to do sometimes their own applications and stuff like this. So to summarize, right, these are the challenges. Applications run slow. It impacts everybody, not operation, actually impacting operations and clients, right? Downtime is very expensive. Still, we know this. Budgets are tight. You don't get 100%, doubling your budget basically from 1 year to another just to buy more storage. If you do, you're very lucky. Keep that job. But typically, we don't. silos of storage, right? This prevents really business agility and simplicity at the end of the day. So what do we do? Okay, so let's talk about some DataCore solutions, right? We have software solutions and we have integrated hardware software solutions as well. So on the left-hand side, you see, the software solutions, enterprise class software solutions that we have. These are around software-defined storage. We call our product SAN Symphony, and we also have a hyper-converged virtual SAN software solution. With those, since they are software only, you can choose your own hardware, right? It's perpetual licensed, so you don't ever lose that license. You can always add to it, but they don't expire. And there are really flexible deployment models. We sometimes call them use cases as well. And I'm going to talk about actually in the next couple of slides. Or if you really don't care about a lot of flexibility, maybe you don't have staff to do it, or you really want to put in software-defined storage architecture quickly in your data center, you could go the Appliance way. It comes predefined, pre-tested, pre-configured. It's easy and fast, really, to deploy. This is called Lenovo DX8200D, powered by DataCore. Actually, it's a Lenovo 3650 server, right? And that runs DataCore software on it. So it's a very easy way and quick way to implement software-defined storage in your operations. It's a Lenovo product, so you call Lenovo for everything, and then they take care of it, the backend, whatever they need to do. Right. So that's a simplistic, simpler way to approach to software-defined storage. So to kind of summarize the application, the appliance Lenovo DX8200D, it's purpose-built turnkey appliance. It's very versatile because you can add memory, you can take out memory, you can add different multiple boxes, things like these, and its performance is really out of this world. And I'll talk about the parallel I/O and why that is, but it's the best performing solution in the market, and we have high availability too. So let's talk about those deployment models, use cases, right? So starting from left to the right. So the one on the left is maybe very typical for implementation. It's a kind of a straightforward model. First of all, you have your compute, your applications, servers, and your storage. They are separated. And this is a configuration where if you want to take advantage of your existing storage and get more out of it, get better speed and more utilization out of it, that's what you do. That's an ideal configuration. And as you see, we have two nodes, which means high availability as well. The next one is the converged server SAN model. That's where you take care of, still you take care of your application separately. It's a separate architecture. Compute is out there on their own servers, running on bare bones or virtualized servers, right? So storage and compute are still separate, but they're in one chassis, and we are taking advantage of the onboard storage of the servers. So this is like a transition from storage virtualization to hyperconverged. But it's a good configuration if you want to keep your applications and compute separate. The next one is hyperconverged. Probably you're all familiar with this, but in this configuration, applications and storage are combined on the same server stream, right? It's consolidated. Why? Smallest footprint, and really for DataCore, highest performance of hyperconverged systems out there. And I'll talk about some testing that proved it. The last one is what we kind of call hybrid converged. this is a consolidated scenario between the hyperconverged. So some of your applications and your storage are on the nodes that you see at the bottom. Still provides smallest footprint, but you might have some applications that you don't want to maybe get hyperconverged. Then you keep them separate, and system supports it. That's a configuration like that. Maybe you have some old ones, right? Fax servers and whatnot. If people are still using faxes, I think they do. So you keep them separate on their own servers, dedicated servers, and you can still have hyperconverged underneath, right? Running most of the stuff. This is very flexible, right? So that's the advantage of it. So moving on to like really data infrastructure, you remember this, the siloed configuration that I talked about before. But digging kind of more into it and say we've now integrated all this as I've shown in the deployment models under a DataCore infrastructure platform. This is the software-defined storage platform that which is our solution. So underneath, software becomes the abstraction layer, right? Between the intelligence that are in the boxes and the interface to the application. So we kind of get that intelligence, unique and siloed intelligence out of these boxes, and kind of combine them, integrate them in that software abstraction layer. What happens then? If you noticed, two immediate benefits you get from this is as follows. Silos became tiers, right? Now we call them tier 1, tier 2, tier 3. Why? Because the software automatically will do storage virtualization. It will create a virtual pool. It will pull all these resources from these separate devices into that pool and start auto-tiering. Fastest become tier 1, maybe it's all flash arrays, right? The second tier may be the hyper-converged. The third tier is whatever that may be. Fourth tier may be your hard disk drives, and fifth tier may be your magnetic media if you still have it. So this will happen automatically, the storage virtualization. And then you see the numbers 1, 2, 3, 4 moved up. So this is a comprehensive set of features, storage services, right? That's provided to the northbound interface. So we take the intelligence out of those separate individual boxes that don't work with each other, and create one single platform that's going to serve very well to the applications above. In addition, next slide is here. Okay. Another one is separating really advances in software and in hardware. They do have their own life cycles, hardware and software. Software tends to be, kind of advanced faster nowadays. But no matter what, some of the features may not actually may not be available in one of those hardware boxes. But software with the intelligence in it makes it look like all these features are homogeneously available to the upper layers. One example is vVols. If you're familiar with VMware's vVols, some of these boxes may not have it because it requires extensive certification to be able to achieve vVol certification. But our software is certified, and it takes care of this. Even though one of your tiers, one of your devices aren't vVol compatible, it will look like compatible to the northbound interface because we are certified that way. So that's one of the things, right? That could be really beneficial. And of course, this envelope, right? This platform provides a single pane of management for all these heterogeneous infrastructure boxes. So another big benefit for simplification. And if you ask about, hey, what are those services, storage services that you provide? It's right here. I'm not going to go over each and every one of them, but I already talked about like auto tiering. There is caching. There is two nodes. Remember, synchronous mirroring is the feature that makes it happen. Asynchronous replication is for disaster recovery. But go to datacore.com to read more about these. I mean, it's very comprehensive. So I'll move on. So I talked about parallel I/O, and I said, it really makes us unique. So I'll talk about the test results first. This is not what DataCore talks about itself, right? This is Storage Performance Council tests that prove that our software is the fastest and price performance is the best. So SPC basically tests vendors' hardware and software integrated together with a database-intensive I/O workload, right? So that, and they have a very extensive and detailed procedure to run these tests. You have to put in everything, including like the UPS that you use to support your servers, for instance. And they run through the tests, and results are actually audited, independently verified, and then published. It's a pretty rigorous testing. And we went through that, and here are the results, right? The first one is 0.22 milliseconds. This is the latency. This is the response time of the system compared with our competitors, right? And as you see, the closest one is NetApp 0.76. Compare it with 220 microseconds. It's huge performance gain in terms of latency. Also, you see price per IOPS here down there. Ours is 10 cents, and the next one is 23 cents. So again, huge gains on price performance. So if you have projects going on, if you're getting ready to start one in hyperconverged or software-defined storage, go to datacore.com and read about us, or go to SPC Storage Performance Council page and pull up the reports and look at what we did. It's amazing and it's revolutionary, and we're using it, this unique technology, in all of our products. So how does it work though, right? So here's how it works. Without parallel I/O, the storage I/O is processed basically serially, sequentially. Remember I talked about a lot of compute out there, resources out there, but maybe not enough I/O processing power. So here is how we kind of show it, right? I/O is serial. So you have a lot of processors, cores on your chips, on your processor chips, but since it's serialized, storage I/O becomes a bottleneck. How do we make it happen then? How do we get rid of that? Well, this system is adaptive. This technology is adaptive. So as the cores become available, and they don't have to be I/O processing cores. They can be other compute cores. We will grab them. Our software will automatically grab them and use for I/O. And if the compute needs more cores, then we're going to release them, and they'll go do their own thing. But in this sense, we use more cores, more processes to process storage I/O. So it becomes parallel. When things become parallel, they go faster, right? But this is a very unique technology our R&D research, they kind of brought in. And again, as I said, we're using this technology in all of our products that makes everything go faster. Or in other words, actually you have to use less hardware to do the same job. Or if you have hardware set up already, you can serve many more clients with parallel I/O than what you used to be able to do. Another benefit, right, is zero downtime, zero touch. So I talked about high availability already. We have an active failover system. So it will just switch over when something goes wrong on one of the nodes. And this will happen automatically. There is no human intervention needed. It will switch over, it will fail over, and when you fix it, it will fail back also automatically. This helps you, especially, for instance, for live maintenance. Right? This is kind of one of the side benefits in addition to high availability or to your data. You can upgrade one system live. You can work on one node. It will switch fail over to the other, and you fix it. You do your own maintenance, and then it will switch back. So maybe no more 2 a.m. Saturday night maintenance windows, right? You can do this during the day. Same configuration. The key point here is you can have these two nodes as close as, different rooms in the same building, or they can be in different buildings, different cities, or even one of the nodes can be on premise and the other one can be on cloud. So the last one is especially interesting to those, for instance, school districts where they are locked into a geo, right? You're not a national enterprise, national conglomerate that you can have two different data centers, maybe East Coast, West Coast, or U.S. versus Europe for disaster recovery. You don't need to, and they can't afford it, and they don't have the geography to do it. Instead, you can have one center on premise, and then the other one can be on the cloud, and it works that way. So here's one great example of bringing in cloud technologies into the fold. To kind of summarize all this architecture discussion, it's an enterprise-wide solution, our SDS product line solutions, right? You can have in your main data center or mainstream services, you can use external arrays, external storage, you can use cloud as a storage. And then it can be, by the way, iSCSI or fiber channel, and a single management console controlling everything. And then in your you can have robo situations, and you can have DR sites, as I kind of talked about in the previous one. So it's an enterprise size enterprise class solution. So a case study, a real quick, right? This is a customer. They're still a customer of ours. It's a hosting company with a lot of different type of clients. So their challenge was they need more storage. They get these performance spikes like Black Friday, Black Monday, all these the holiday season performance spikes that's needed. And critical applications must be available 24/7. All this, especially rapid provisioning. You're a web hosting company. One of your clients, one of your customers calls up and says, "I need this much storage urgently." You really can't take 2 days, right, to provision that storage. It has to be within hours or minutes. You can't really charge more than what those giants out there are charging, the Amazons of the world, right? You have to be low cost. So what did we do? They purchased a DataCore solution, worked with our experts, and it's a 4-node configuration, resulted at 20% more capacity, maybe more importantly, 5 times faster than what it used to be, and 42% cheaper. A visual depiction would be great here. So here is On the left-hand side, one reputable vendor, really well respected. That's what they proposed. Two full racks of equipment, basically, and what they ended up with from DataCore. Much smaller footprint. It's faster, smaller, it's cheaper, and it has much more capacity in it. For especially a web hosting company like this in a data center, right? That space is very expensive, so they really appreciated this small footprint. And as their CIOs put, that was a no-brainer, right, to go with DataCore. So they did. Coming to the end, to summarize, right, DataCore benefits. Again, these are all from research that we do with our customers, and this is something actually that we validate with third-party vendors and third-party researchers as well. We've seen that 79% of our customers saw improved performance, right, by 3 times or more. 83% of them saw the reduced storage-related downtime by 50% or more. And then 81% reduced storage-related spending by 25% or more. And in terms of saving money, all of them in the first year saw positive ROI in their investment with DataCore. So these are amazing benefits that we can quantify like this. So to summarize next steps, right? Again, thank you for listening to me. You can learn more, obviously, by visiting our website at www.datacore.com. You can always call us. You can email us at info@datacore.com. If you have any projects that you're considering, do go to our website and request a live demo with one of our technical experts. They'll get online. It's not a sales pitch. They'll, try to understand what you want to see, and then they'll help you. And you can also download, our free software trial from our website as well. So looking forward to maybe talking with you or seeing you later. And again, thank you for your time listening to my presentation today. Take care.